Hi class, now that we have learned how to graph a rational function, now let's talk about its domain and its range. So what the x values can be and what the y values can be. Looking at this first one, the domain is always going from left to right. So if we take a look at this graph right here goes infinitely to the left. It goes infinitely down, even though the arrows aren't on there, it's implied. It goes infinitely up, and it goes infinitely to the right. Okay? So here's what's happening. Your graph starts at negative infinity, and then it's going to the right, it's going to the right, it's going to the right, it's going to the right. Now notice right here, it's still going right, it's still going right, it's still going right. It's going right very, very, very slowly, but it is still going right until what point? Until it reaches a vertical asymptote, correct? And that vertical asymptote is the line. Our vertical asymptotes will always be an integer, so this line right here is your vertical asymptote. So your graph goes as far right as that asymptote, and that asymptote is a negative 3. So it goes from a negative infinity to a negative 3. And then it stops. However, it picks up again, doesn't it? It picks up right here. So just on the other side of a negative 3. And once it starts up there, then it goes on to positive infinity. So it starts at negative infinity, it goes to the right, 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 it stops at a negative 3, picks up again at a negative 3, and shoo, goes to positive infinity. So here's how we're going to write that in set and interval notation. I always like to start with interval notation. That's the one that uses parentheses and brackets. It starts at negative infinity, and how far to the right does it go? It goes to the right to our asymptote, which is a negative 3. It does not ever touch negative 3. An asymptote is something that it approaches, but it never touches, so we use a parenthesis there. So negative infinity to a negative 3, parenthesis. We have more x values, so that's when we say we have a union. We pick up again at a negative 3. It doesn't touch it, so we use a parenthesis. And it goes all the way to positive infinity, parenthesis. So for our set notation, what we're going to write for this one is it's really all the real numbers except for one. Yes? It's all of these x values except for one, that x value. It cannot equal a negative 3. So here's how we're going to write that. We're going to write x such that x belongs all the real numbers, comma, except x cannot equal a negative 3. So x cannot equal a negative 3. And that's how we're going to write this for our set and interval notation. So now let's do the exact same thing for our y values. Our y values, once I get rid of this asymptote, there we go. Our y values go from the bottom up. So this arrow, this blue one right here, it goes all the way down to negative infinity. So that's where it starts. And how high does it go? It goes as high as my asymptote, which my asymptote in this case is this line. Y equals 0. So it goes to 0, and then it picks up on the other side of 0, and it shoots, and it goes all the way to positive infinity. So negative infinity to 0, and then from 0 to positive infinity. There's going to be your range. Negative infinity to 0, union 0 to positive infinity. It doesn't include 0, so that's why we put parentheses at both of those spots. So y can be any number that exists except for 1. It cannot be the number 0. So y such that y belongs all the real numbers except y cannot equal 0. And there is the correct answer for problem number 1. Let's try the same thing here now for problem number 2. All these rational graphs do look very similar, so their domain and ranges are going to be similar. It goes to negative infinity, positive infinity, negative infinity, to positive infinity. So we're going to start with our domain, going from left to right. It starts at negative infinity. Oofta. And it goes as far right. Now I ruined my arrows. And it goes as far right. Oofta. Here we go. Get it together, Birdie. Negative infinity, and it goes as far right as 0. It picks up again at 0 over here, and it goes to positive infinity. So from a negative infinity to 0 does not include 0. And then it goes from 0 to positive infinity. Union 0 to positive infinity. It always goes up to your asymptote class, and the asymptote right here is x equals 0. Your asymptote for your y value is this one, which is y equals 1. So for your range, it goes from negative infinity, it goes as high as 1, picks up again on the other side of 1, and it goes to positive infinity. So it's going to go from negative infinity to 1, union 1 to positive infinity. So for both of these, it's x such that x belongs all the real numbers, and y such that y belongs all the real numbers, except there's one x value that does not exist. That is, x cannot equal 0, and there's one y value that cannot exist. That's y cannot equal a positive 1. So there we have our domain and range for set interval notations for number 2. You guys pause the video and try number 3 and number 4 on your own. This one's kind of crazy. There's 2 vertical asymptotes, isn't there? There's one right here, which is at the line x equals negative 4. X equals a negative 4. And there's one right here at the line x equals a positive 3. So for our domain, we're going to start at negative infinity. It goes as far right as our first asymptote, which is a negative 4. We're going to have a union. It picks up again on the other side of negative 4. And then it goes as far right as a positive 3. We're going to have another union. And then it picks up again at 3. And it goes all the way to positive infinity. So here it is, starting at negative infinity. It goes as far right as a negative 4. Because then it approaches the asymptote but never touches it. And then here it starts at negative 4, and it goes as far right as a positive 3, but it doesn't cross positive 3. It only gets closer and closer and closer to it. And then it picks up again here at negative 3, and then it goes to positive infinity. So here we have our domain. And for our set notation, it's going to be x such that x belongs all of the real numbers, except for 2 of them. X cannot equal a negative 4. And x cannot equal a positive 3. There's only one horizontal asymptote, and that horizontal asymptote is the x-axis, which is the line y equals 0. So it goes from a negative infinity till 0, union 0 to positive infinity. So y such that y belongs all of the real numbers, except y cannot equal 0. And there is your answer for problem number 3. Last one, problem number 4. We have a vertical asymptote at x equals 3. And we have a horizontal asymptote at y equals 0. So your domain goes from a negative infinity till 3, union 3 to positive infinity. X such that x belongs all of the real numbers, except x cannot equal a positive 3. And your y value starts at negative infinity. It goes as high as 0. It approaches it, never touches it, and then it picks up on the other side of 0. So we have a union, and it goes from 0 to positive infinity. And there's your answer for problem number 4. Oh, set notation, y such that y belongs all the real numbers, except y cannot equal 0. And there is how you do domain and range for rational functions. Let me know if you have any questions when you get to class tomorrow.